so to get us back on track, to kind of move forward to what we're looking for here, right? So our assignment that we're kind of preparing for this week is what you would call a perforated panel, right? So we need a 2D perforated panel and we need a 3D perforated panel. So in order to understand how to do it in 3D and what the difficulties are, I first want to show you and get out of the way basically what it means to start doing perforations in 2D, right? So we're going to kind of be doing that a lot here for the rest of the week here. So anyway, what I'm basically going to do at this point is to just kind of create a larger surface. I'm going to do it sort of manually, not so smart first, and then I'm going to do it a smarter way later on, okay? So right now, I'd like you to just kind of make two panels, and it doesn't matter how big they are exactly, and it doesn't really even matter what shape they are. Just two panels in the XY plane, just like this. And then from there, it's really just a process of taking that middle one, and we're going to use that in order to generate circles, right? So now we're going to use our divide domain squared method. We're going to divide it, then we're going to grab points, and we're going to build circles into it. Okay, so oh, you know what? I want to do it slightly differently, actually. So a different way of subdividing a surface, right? So if you don't want to use divide domain squared, and there's a reason why, and I'll explain it probably when it becomes appropriate, but it has to do with the fact that when we have our deconstructed vertices, they come out in groups of 4, which means every time I have a connection, turn all these off, every time I have a connection point between panels right here, that point right there actually has 4 points. So if I make a circle that I'm going to cut out of it, I'm actually making 4 circles. And then the second one that it tries to cut doesn't have anything to cut, and so it just stays as a solid. Okay, so we'll get into more of that when it becomes appropriate. But on this one, the simpler way of dividing a surface is to use, under utility, this one right here. It's called divide surface. And if you read the description, it just says that it generates a grid of UV points on a surface. So none of the hubbub about, you know, the cells, the faces, no edges, no nothing like that. All it does is just kind of break it down into a point grid on a warped surface. So we're going to drop that in. And it's going to request that we reference the surface. It's going to ask for a UV count as well. So for simplicity's sake, I can kind of just jump back up here and copy all this down. Copy, paste, and drag it down. And then select that surface and set it to the inside surface that you've just generated. And go ahead and just plug them all in. So we've got S, U, V. And that's really, really hard to see on the screen there. But if I click on surface divide, or divide surface. If I click on divide surface there, you can see that it just generated a giant grid of points. I'm going to spread them out a little bit here. Like that. Okay, now, UV tree. Oh, yeah, that's right. So the cool thing is, well, no, I'm not going to go there yet. Anyway, so for simplicity's sake, the points as a tree. Points as a tree is really neat because they're, well, what was I going to say? I lost my train of thought. There's like another step, but we'll get there. I'll be reminded of it when I need it. But anyway, what we need it for now is just to generate circles. Right? We're going all the way back to like our basic circle generating pattern. So go up to curve and primitive, and bring in the circle. And so this is going to have the base plane where we can just plug the points list into the base plane, and you'll see that it generates those circles right here. And then we can change the radius with a slider. I'm going to say 0 less than 2.5 less than 10. The important part is the decimal, I'm guessing. And so my circles look like this, with this kind of density. So at this point, what we're going to do is a subtraction method. So you guys are familiar with subtraction, for those of you who have used pretty much any architectural modeling software before. All you have to do is just kind of trim out using another positive geometry in order to create a negative. So if we create these circles here, we can reference the surface and then subtract out the circles, but the circles will have to be converted to a solid. So remember how I showed you the rectangle? If you just plug a rectangle profile into a surface param, it just makes it a solid. We can do that with circles as well. So let's go up to param, and we're going to go to geometry, and we'll use surface, and just put it right here and make it a surface. So now you'll see in Rhino that they actually have a surface to them. Am I losing any of you? Moving too fast? Speed's okay? All right. The next thing I need then is to reference the overall surface. That's this one right here. And it's really just a factor of bringing in another surface param. So I'll right click and I'll set one surface. Now you'll see that one is fully referenced. And I do think this is going to give me an error when I do this. So these are the two I'm going to do, the outside surface, the inside surface. I'm going to just kind of go down here and turn off that layer in Rhino so that all I have left are my Rhino, or my Grasshopper surfaces. And the tool that we need in order to do the subtraction, it's under surface, no, sorry, it's under intersect. This is our first Boolean operation that we're using. Under intersect, under shape, we're going to use solid difference. So it works just like the Rhino function for subtract or Boolean difference. It's going to ask for the first B-rep set, and then it's going to ask for the set to subtract with, I believe. It might be backwards. I always forget. So anyway, I'm just going to take the original surface and I'll plug it into A. And then I'll take my circles and I'll plug it into B. And it's important for this exercise to make sure that you turn off all the old geometry, otherwise you're not going to see what was really created. So I'll turn off all this, turn it off. And what I notice is that my surface is still solid. So I can basically begin troubleshooting why. I see part of why. I see that I have one referenced B-rep set, and I have all of these other B-reps are broken out into groups. So if I flatten that input, that's going to be a step in the right direction. So then the next thing that I'm not quite sure of is whether or not it's asking for the subtracting geometry first or second. So sometimes with these Boolean operations, I like to swap them. Ooh, I just made a mistake. Yeah, let me swap. Sorry, I'm going to disconnect first. With this, you should probably disconnect first. And you have to move your flatten to the other side, so I'll flatten up there. Put this here and this there. That is not it. And if it's not that, I'll go back to the first status here. This one. If it's not that, then my thought is that it could be a flipped surface. So if your Z on the surface is opposite, then it might not cut. So I'm going to try to use flip surface, which should be under surface utility and flip. Oh, shape, actually. So this can flip a couple things. It'll flip a surface or like a guide, but you should be able to just plug one of the surfaces into flip and then replace it down here. Oh, darn. Huh. What am I doing? Hang on, I gotta troubleshoot. So that's facing down. That looks like it's still facing down. These look like they're facing up.
It's supposed to be like this?
Yes.
Okay. I did the exact same thing you did.
It probably has to do with the way you created your surface and the direction that it goes when you create it. So here's what I'm going to do. I'm going to take this surface and manually flip it over, which isn't smart. Oh, wait, wrong one. Yeah, actually, that might be right. Yeah. Okay. I don't know why my flip didn't work, but it should have. So anyway, the mystery here is that for some reason flip wasn't working. So I'll have to do some troubleshooting to figure out exactly why. But anyway, once we figure out what's, the way that you've created your surface, it might have turned your surface normal down versus up. If my dots are facing up, or perforation circles are facing upward, and the surface that it's trying to cut it from is facing down, right? And you see that the dark maroon is there amidst the bright pink red, then they're not going to be able to trim from one another. So you'll have to flip a surface or figure out how to get that flip one to work. It's never done that to me before, but anyway. So this is perforated panels. And we're going to get into a lot more detail on them later on, but what questions do you have so far? Yes?
So you basically just flipped it in Rhino? You just...
Yeah, I did a manual flip in Rhino because the flip function was not working, and I don't know why, but I will figure it out. Okay. All right, so I'm going to stop this, and then we'll move on. We'll take a little break, and then we'll move on.